This $40 device generates electricity around the clock with no fuel, no batteries, and no solar panels. It runs in total darkness, outlasts a $15,000 lithium battery bank, and at peak capacity keeps a fridge running indefinitely. Yet despite the physics being proven since 1831, it doesn't appear on a single federal rebate list. It's called a permanent magnet generator. By the end, you'll know what it is, how it works, and how to build your own. Let's dive in. Right now, if you want energy independence, you're told to drop $10,000 to $15,000 on rooftop solar and a lithium battery wall unit. So let's look at what that setup is actually costing you and why it quits exactly when you need it most. The average residential solar installation in the United States runs between $20,000 and $35,000 before incentives. After the federal tax credit, you're still looking at $14,000 to $24,000 out of pocket. And the battery storage that makes it all useful at night, a Tesla Powerwall costs around $12,000 installed and holds 13.5 kilowatt hours of usable energy. That's enough to run your essentials for maybe half a day. After that, you're back on the grid. And none of that accounts for maintenance. Panels degrade, microinverters fail, wiring corrodes. The average rooftop system needs its first service call within 7 years. But here's the part nobody puts in the sales brochure. Lithium iron phosphate batteries lose roughly 20% of their capacity within the first 10 years. A Powerwall installed today will be storing only about 80% of its rated energy by 2036. Your 15-year-old panel system will still be producing, but the battery catching that power will have already started dying. And when it does, the replacement costs the same as the original. Now compare that to a device you can hold in one hand. A permanent magnet generator built from about $40 in raw materials. That's a stack of neodymium magnets, a spool of copper wire, a pair of steel rotor discs, and a bearing. It has no fuel input, no chemical degradation, no software updates, no inverter to fail. It generates electricity the moment something spins it, a trickle of creek water, a breeze you can barely feel on your face, a hand crank in the dead of night. And when you see what it costs to run per month, you'll understand why no power company wants you to know about it. And this isn't some backyard novelty. The physics behind this device is the same physics that runs every hydroelectric dam, every coal plant turbine, and every nuclear generator on Earth. The only difference is scale and a set of magnets that didn't exist until 1982. So how does a $40 stack of magnets and copper wire produce real usable electricity? The answer is a principle called Faraday's law of electromagnetic induction. In plain language, when a magnet moves past a coil of copper wire, the changing magnetic field forces electrons in the wire to flow. That flow of electrons is electricity. It doesn't matter how the magnet moves, spin it, slide it, shake it. If a magnetic field is changing near a conductor, current flows. That's not theory. That's the operating principle behind every power plant on the planet. Now, if you're thinking that sounds too simple to actually power anything useful, a research team at the University of Strathclyde in Scotland tested exactly that. They measured the output of hand-built axial flux permanent magnet generators and found that a well-tuned unit produced up to 1,200 watts in moderate wind. That's enough to run a standard refrigerator, a set of LED lights, and a charging station simultaneously. And the device they tested was built from scrap steel, hand-wound copper coils, and off-the-shelf neodymium magnets. The specific generator design is called an axial flux alternator. Think of it like a magnetic sandwich. You take two steel discs and mount powerful neodymium magnets on them in alternating polarity. North, south, all the way around. Between those two discs, you place a ring of copper coils, each one wound from thin magnet wire. When the magnet discs spin, the alternating poles sweep past the coils and induce an alternating current. No brushes, no commutator, no gears, just magnets, wire, and motion. But here's where it gets even more interesting. The most advanced version of this generator doesn't use ball bearings at all. It uses magnetic levitation. By stacking ring-shaped neodymium magnets with like poles facing each other, the rotor floats above the base on a cushion of magnetic repulsion. This eliminates mechanical friction almost entirely. A conventional wind turbine needs wind speeds of at least 3 MNOs before its bearings allow rotation. A magnetically levitated version starts generating in wind as low as 1.5 ms. That's barely enough to rustle a flag. And because there are no bearings to wear out, no lubricant to degrade, and no contact surfaces to grind, the estimated operational lifespan of a maglev generator stretches into decades. Some engineers have projected 500 years for large-scale maglev turbine structures, though that number remains theoretical. The point is this: a conventional turbine's bearings are a ticking clock. Replace the bearings with magnets and the clock stops. And the energy savings from eliminating friction are not trivial. A conventional small wind turbine loses up to 30% of its captured energy to bearing drag, especially at low speeds. At the exact moment when wind is lightest and every watt matters most, friction eats the output. Magnetic levitation recovers that loss entirely. And here is the part that should frustrate you. None of this is new. None of it is experimental. This is proven physics, and it has been understood for nearly 2 centuries, and almost nobody is building with it. To understand why that matters, you have to go back to the very beginning. The oldest known reference to magnetic force appeared around 600 BC. The Greek philosopher Thales of Miletus noticed that a dark heavy stone found near the region of Magnesia attracted pieces of iron without being touched. He called it a lodestone. He didn't understand why it worked. He actually believed the stone had a soul, but he documented it, and that record became the first written observation of magnetism in Western history. On the other side of the world, Chinese scholars documented the same phenomenon independently around 300 BC. They called it Qishai, the compassionate stone, because it reached out and pulled iron toward it. By the 2nd century BC, the Chinese had turned this principle into the first magnetic compass. 2 civilizations, separated by thousands of miles and no shared language, both discovered the same invisible force and tried to put it to use. But the leap from magnetic curiosity to magnetic electricity didn't happen until August 29, 1831. On that day, in the basement of the Royal Institution in London, a self-taught bookbinder's apprentice named Michael Faraday changed the world. He wrapped 2 coils of copper wire around an iron ring, connected one coil to a battery, and watched a galvanometer needle on the other coil jump. He had just demonstrated electromagnetic induction. Within months, he built the first electric generator, a copper disc spinning between the poles of a horseshoe magnet, producing a continuous direct current. Every generator built since, from the turbines at Hoover Dam to the alternator under the hood of your car, descends directly from that experiment. But the magnets Faraday used were weak. Natural lodestone and early steel magnets could barely hold a paperclip at arm's length. It took another 150 years before magnets became powerful enough to make a truly practical small-scale generator. That breakthrough came in 1982. In a laboratory in Osaka, Japan, a material scientist named Masato Sagawa was trying to solve a cost problem. The strongest permanent magnets at the time were samarium cobalt, and both elements were expensive and scarce. Sagawa believed he could replace them with neodymium and iron, 2 of the most abundant metallic elements on Earth. He had pitched the idea to his supervisors at Fujitsu Laboratories and been turned down. So he resigned. He joined Sumitomo Special Metals and within a year had synthesized a new compound, neodymium iron boron. At the same time, 6,000 miles away in Detroit, a General Motors researcher named John Croat had arrived at the exact same formula independently. Neither knew the other existed. In November 1983, they both presented their results at the same magnetism conference in Pittsburgh. The room realized 2 teams on opposite sides of the planet had just invented the same magnet. It was 10 times stronger than ferrite, compact enough to fit in a pocket, and cheap enough to mass produce. The neodymium magnet changed everything. And yet, 40 years after that discovery, the number of American homes running a permanent magnet generator built from these magnets is effectively 0. The technology is real. The magnets are available on Amazon for $12 a pack. The physics has been verified by every university physics department on Earth, and almost no one is using it. But the proof that it works isn't hard to find if you know where to look. On the Scorig Peninsula in the Scottish Highlands, a community of about 70 people has lived entirely off-grid for over 40 years. There are no power lines, no roads, no gas mains. Their electricity comes from hand-built permanent magnet generators, most of them designed and installed by a man named Hugh Pigott. Pigott moved to Scoraig in the 1970s with no electricity at all. He started building wind turbines from scrap metal and hand-carved wooden blades, and he never stopped. His designs use axial flux permanent magnet alternators built from neodymium magnets, hand-wound copper coils, and steel discs that can be cut with basic shop tools. Over 4 decades, he refined those designs into an open-source manual called a wind turbine recipe book. As of 2021, more than 1,000 of his turbines have been built in over 25 countries, from Scotland to Nicaragua to Nepal. If you want to power, heat, and cool your home off-grid, the Passive House files show you how. Full plans, exact materials, and the honest numbers nobody else gives you. It's not too late to start lowering your bill. Scan the QR code and see for yourself. In Nashdafan, a village in northeastern Iran, 30 mud brick windmills have been grinding wheat using nothing but wind and vertical wooden blades for roughly 1,000 years. They are called asbods, and they are the oldest wind-powered machines still functioning on Earth. Built from clay, straw, and wood, they convert the region's brutal 120-day summer winds into mechanical energy. That energy drives grindstones without a single gear, bearing, or electrical component. The 40 structures together produce approximately 150 kilo of ground wheat during each wind season. These machines predate every European windmill by at least 4 centuries. In a 2024 study at the New Jersey Institute of Technology, researchers built and tested a magnetically levitated vertical axis wind turbine using a direct drive neodymium generator. With a blade solidity of 0.545, the maglev system achieved the highest efficiency and tip speed ratio of all configurations tested at 0.56. The turbine operated at wind speeds that would have left a conventional ball-bearing turbine motionless, and the total materials cost for the prototype was under $200. Every one of these examples is real, documented, and measurable. And yet, the total number of permanent magnet generator installations listed on any United States federal incentive program is 0. So if the physics is nearly 200 years old and the magnets have been commercially available since 1985, why isn't this standard? The open source plans have been downloaded in over 25 countries, and yet it remains invisible. The answer is not a conspiracy, it's a structure, and once you see it, you can't unsee it. Start with zoning. Most municipal zoning ordinances in the United States impose a 35 FT height restriction on residential structures. A wind turbine needs to be 20 to 30 FT above the tallest obstruction within a 300 FT radius to catch clean, unobstructed airflow. In a suburban neighborhood with 2-story houses and mature trees, that means you need a tower of at least 60 FFT. Your zoning code says 35. You're already illegal before you pour the first footing. Now add setback requirements. Most jurisdictions require a turbine to be set back from property lines by at least 1.1 times its total height. On a standard 1/4-acre suburban lot, that setback alone consumes most of the available space. The turbine is structurally safe. The physics is sound. But the lot is too small for the law, even if it isn't too small for the wind. Next, consider the electrical code. The National Electrical Code requires all grid-tied renewable energy systems to use inverters listed by a nationally recognized testing laboratory, typically UL listed. A hand-built axial flux generator wired to a battery bank in a charge controller doesn't carry a UL listing. It can't. UL certification costs tens of thousands of dollars and is designed for manufactured products, not one-off builds. So even if your generator works flawlessly, your local electrical inspector has no mechanism to approve it. Then there are the homeowners associations. A 2018 survey by the Community Associations Institute found that over 74 million Americans live in HOA-governed communities. Many of those HOA covenants include blanket restrictions on exterior structures, antennas, and anything that alters the roofline or visual character of the property. A wind turbine, no matter how small or quiet, violates those covenants in most cases. And fighting an HOA costs legal fees most homeowners can't afford. This isn't hypothetical. In 2001, a homeowner named Bob Lobelins in Dover, Massachusetts, applied for and received a building permit to install a small residential wind turbine on his farm. 3 months later, before the installation was even finished, the permit was revoked after neighbors complained. What followed was a 13-month legal battle involving expert witnesses, public hearings, and thousands of dollars in attorney fees. The permit was eventually reinstated, but the message was clear. Even when the law is on your side, the process is designed to exhaust you. The system wasn't built to suppress magnetic generators. It was built around centralized power generation, standardized equipment, and certified installers. Anything outside that framework, no matter how efficient, how cheap, or how well proven, becomes invisible. It doesn't get banned, it gets excluded. An exclusion is quieter than a ban, but just as effective. We are told that energy independence requires a $20,000 solar installation, a $12,000 battery, and a certified electrician. That is the expensive, complex, failure-prone path. A permanent magnet generator built from $40 of raw materials is the simpler path. It spins on a magnetic bearing that will never wear out. It runs on a breeze that costs nothing, and the system was never designed to accommodate it. But the system doesn't have to hand this to you. Here is how you build it yourself. The core of a permanent magnet generator is the magnet rotor assembly. You need 12 to 16 neodymium disc magnets, grade N42 or stronger, typically 20 mm diameter and 10 mm thick. A pack of 12 from K&J Magnetics in Pipersville, Pennsylvania, costs between $15 and $20 at current retail prices. Mount them in alternating polarity on 2 steel rotor discs. These can be cut from 1/4 in mild steel plate at any local metal shop for around $5 to $8 per disc. The stator, the stationary part that holds the coils, uses 9 hand-wound coils of 20-gauge enameled copper magnet wire. A 200 FT spool costs around $10 to $12. Wind each coil to approximately 120 turns around a simple wooden jig. Set the finished coils in polyester resin on a flat mold to form the stator disc. The resin runs about $6 for a small batch. Bearings are the only other essential component for a basic friction-based build. A sealed ball bearing from a scrap car wheel hub works well and costs nothing if salvaged. For a magnetic levitation build, replace the bearings with a pair of stacked neodymium ring magnets mounted in repulsion. This eliminates all mechanical friction and extends the operational lifespan by orders of magnitude. The total materials cost for the generator assembly alone runs between $35 and $50 depending on magnet grade and wire gauge. Pair this with a simple Savonius-style vertical axis wine rotor. You can build one from a split PVC pipe or a repurposed 55-gallon drum. The complete wind-to-electricity system comes in under $100. Hugh Pigot's wind turbine recipe book, available through Scoregg Wind Electric, provides the most thoroughly tested open-source plans for axial flux generators. Designs range from 1 motors to 4.2 motors in rotor diameter. The Wind Empowerment Network, a global nonprofit, offers workshops in construction and installation for magnets. K&J Magnetics in Pennsylvania grades and tests every unit before shipping. One warning: do not buy cheap, ungraded neodymium magnets from unverified overseas sellers. Magnets that aren't properly graded may be weaker than advertised. An inconsistent field strength across a rotor will cause vibration, voltage imbalance, and premature failure. Spend the extra $3. Get graded coated magnets from a known supplier. The build itself requires no specialized skills beyond what most people who've used a drill and a soldering iron already have. Winding copper coils takes patience, not expertise. Cutting steel rotor discs takes a metal shop or an angle grinder with a cut-off wheel. Most documented builds from Pigot's plans take a long weekend for the generator and another day for the rotor and tower. You do not need an engineering degree. You do need a tape measure, a sense of care, and the willingness to read a manual twice before cutting anything. And be honest with yourself about the scope. A $40 generator is not going to replace your entire electrical panel overnight. At peak output, in a steady 10 mph breeze, a well-built small unit produces between 50 and 200 watts, depending on rotor size. That's a refrigerator. That's LED lighting for a cabin. That's a fully charged phone every single day. It is not a central air conditioner. Scaling up to whole house power requires a larger rotor, a taller tower, and a battery bank, which moves the cost into the hundreds, not the tens of dollars. The second limitation is wind itself. If you live in a dense urban area with buildings on every side, You don't have wind, you have turbulence. A rooftop-mounted microturbine in a city will underperform its rating by 50 to 70% in most conditions. This technology works best in rural, semi-rural, and coastal environments where there is consistent, unobstructed airflow. If your property has mature trees on all sides and you're in a valley, a micro hydro setup or a different energy strategy may serve you better. The permanent magnet generator is built from 200-year-old physics. It's powered by magnets that two separate teams on opposite sides of the world invented in the same year, and it produces electricity from motion so slight you can barely feel it on your skin. It costs less than a tank of gas, it runs without fuel, and the regulatory system that governs American energy has no category for it, no rebate for it, and no incentive to acknowledge it exists. A lot of what this channel covers sits outside the framework that the energy industry built for itself. Not because the technology failed, but because the system was designed around equipment that requires service contracts, certified installers, and recurring revenue. A generator you build once and never pay for again doesn't fit that model. If discovering how to power your home without permission from the grid matters to you, subscribing and sharing is the simplest way to keep this kind of knowledge alive. Now, I have a question for you, and I'm genuinely curious which way you'd go. If you had both a reliable water source and a reliable wind source on your property, which would you build first? A micro-hydro permanent magnet generator for steady baseline power, or a maglev wind turbine for higher peak output? Drop your answer in the comments. And one last thing worth checking. The Nashdafan Asbeds in Iran have been grinding wheat with nothing but wind for roughly 1,000 years. No electricity, no maintenance crew, no replacement parts from a factory. If that doesn't make you question why your power bill went up again this month, nothing will. If this exploration of hidden energy technology has changed the way you look at the power grid, please subscribe and like the video. We are dedicated to uncovering the history and the science that they have tried to keep buried. Take control of your energy future. The next vault of knowledge will be opened very soon.